We take a quick look at linear regression and StatCrunch. So can you estimate the temperature on a summer evening just by listening to crickets chirp? Well, in our table, we have several measurements at which we witnessed the number of chirps at different temperatures. And so here we have the temperature and we have the number of chirps at that temperature. And so we're going to plot this on a scatter plot. And so by plotting this on the scatter plot, we can fit a line to this, and hopefully there's a best fitting line we're going to call the least squares regression line. That'll be a good model. And it does appear that we have a strong linear relationship just by looking at the graph. So what we're going to do in StatCrunch, choose Stat, Regression, Simple Linear Regression. The input variable will be the number of chirps. We'll witness that, and then we'll use that to predict a y value, the temperature. So I'll compute that. So in the table now, we've got several values, but up here at the top, we have the temperature is going to be equal to 37.7 plus 0.23 times the number of chirps per minute. And so if we were to estimate the temperature based upon hearing 140 chirps per minute, we just simply use the regression line, plug in the 140, and we get approximately 70 degrees Fahrenheit. So the question is, how reliable might that be? Well, one way to measure the strength of a linear relationship is to look at the R value. R is the correlation coefficient. And so it's always going to be between -1 and +1, and the closer it is to +1 or -1, the stronger the relationship. So this one is really, really close to +1. So this indicates that we have a very strong linear relationship with a positive association. A step further, if we look at R squared is referred to as the coefficient of determination. And this indicates that 98% of the variation that we witness in the temperatures is explained by the regression model as it relates to the number of chirps per minute. So here we have a very strong linear relationship and what should be a very good model for making predictions. Just remember, as you make predictions, consider the data that was used to create the model. So here, the number of chirps per minute was always between roughly 80 and 200. So as long as you pick values to put into this equation between 80 and 200, this should be a fairly good model. Don't extrapolate. So if you hear 30 chirps per minute, or if you hear 400 chirps per minute, this model may or may not apply. This was the data that was used to create the model, and so this is the kind of data that's most appropriate in the use of the model.